profesor Shyh-Jiann Hwang es actualmente el director general del Centro Nacional de Investigación en Ingeniería Sísmica de Taiwán, que es un centro de investigación fantástico en términos de su tamaño y de su alcance, que fue construido después del sismo de Shyh-Jiann en Taiwán. Y el profesor Hwang nos va a hablar sobre los programas de rehabilitación sísmica de edificios escolares en el Taiwán. Muchas gracias. Adelante, profesor Hwang.
Okay, good morning, ladies and gentlemen. My name is Shyh-Jiann Hwang. I am currently the director of ANCRE, that's the National Center for Research on Earthquake Engineering. It's my great pleasure to speak in this meaningful conference. So I would like to show my gratitude to the organizing committee for your kind invitation. So my topic is the Seismic Retrofitting program of the school building in Taiwan. Before my speech, I would like to introduce my institution, ANCRE. ANCRE was established at the National Taiwan University in 1990, and our mission is the pre-earthquake preparation, emergency response, and also the post-earthquake recovery. So we have our headquarters in Taipei, and we also have Taipei laboratory as well as a new Tainan laboratory. If you have the chance to visit Taiwan, please let us know. We are glad to show you that our institution of ANCRE. So my speech will be divided into 5 parts. First, with a background of introduction, and then I will show the technology that we developed for evaluation and the retrofitting. Also, the school retrofitting project. This project was carried on for 12 years already and almost finished. And we have a new project on hand. That's a residential building program. I also would like to show you the special characteristic. And then I will draw my conclusion. So for introduction, as you can see, that Mexico and Taiwan, we all are located in the Ring of Fire. And we have a big earthquake, but our schools are quite vulnerable. So during the earthquake reconnaissance, you can see that we have the collapsed building of the school. So that's very dangerous, and we have to do something, to prevent this tragedy. So in Mexico, I believe you already have a very good technology. For example, you can retrofit the school building using the post-tension rod. So that's a very attractive technology, and therefore we cooperate with Professor Alcocer in the year 2007. So in Taiwan, we have in situ school testing in Tainan, and we have 2 building units. One without retrofitting. Here is the curve with a blue, but if we retrofit using the post-tension rod, you can see that the strength can be greatly enhanced. So this is a very advanced technology, and I think that Taiwan and Mexico, we have a strong tie, in the long run. So let me introduce the evaluation and the retrofitting technology that we have. So since we have a lot of school volume, and therefore we need the screening process. So we begin with a simple survey. Simple survey, we use a very coarse match, and followed by preliminary evaluation, and then we use the most refined mesh, that's the detailed evaluation, to find the dangerous school building for retrofitting. So simple survey is that we invite the college student to have a field investigation during the summer and the winter vacation. So they stop at site to see all the school building. The school building should be included in this project if the building constructed before 1999 or the building occupied by student and the teacher. So that's a building we need to pay special attention. So for preliminary evaluation, we use the seismic index. So that's a capacity to demand ratio. So capacity, we use the column area in the first story times the average column strength. And we also include the first story, the wall strength. As for demand, we are using the side acceleration times the mass. And therefore, we can have a simple index to indicate the priority. And for detailed evaluation, we would like to use the performance-based engineering. So it means that we have to handle the base shear as well as the lateral deformation. Since we know the deformation, then we can understand the damage status more closely. So for this detailed evaluation, we use the nonlinear static analysis technology. So we developed the pushover analysis. First, we find out the capacity curve, that's the base shear versus roof displacement. And then we revert into capacity spectrum using the single degree inverse pendulum. Then by defining the performance point, then we can get the performance target ground acceleration, AP. Once we have this value, then we can compare with the co-specified value to see whether or not it's qualified. So in order to perform the nonlinear static analysis, we have to have the model, for all the vertical member. Take column as an example. So we would like to put two fracture process hinge at top and the bottom. So that's a lateral load diffraction curve of the fracture behavior. And this is well known. But we also need to include the shear process hinge. But unfortunately, and the shear behavior is not still under discussion. But in Taiwan, since our current strength is very low, and also most of the school building were constructed before the seismic code available, and therefore the school building we have the less transverse reinforcement. So low air primacy and the less transverse reinforcement make all the column as a shear critical column. So we have to resolve the shear behavior before we can use our analytical method. So in the reconnaissance in Taiwan, you can see that we have a lot of column value for short column, typical column, and also the shear wall subject to shear value. So in Anchorage, we have a lot of research on the seismic capacity of the member. So we use the static test on the strong floor. We also using the shaking table test for the column as well as the wall. Most important is that we have the major curve, but we use that to calibrate our analytical model. So then for member-wise, that's the way we do it. For the fracture behavior, I would like to mention that for fracture shear behavior, and most important with the collapse, how to define it. As shown on the left photo, you can see a major shear crack occur. And that's a shear failure occurred at the lateral displacement of delta S. But at that time, the vertical load, NU, can be still maintained. And unless you have a larger lateral displacement delta A, and we lost the gravity load carrying capacity, that's a collapse. This model was developed by Elwood and Maley in the year 2005. And they are empirical equation, but very useful. So we include this model into our analytical procedure. But before that, we have to test it. So we use the shaking table test for the column collapse behavior. Let me show you one example. Here is a frame test in Anchorage using shaking table. On the right, we have two columns. It's a non-ductile column, and therefore totally collapsed. So we use this kind of shaking table test to check the delta S and the delta A, that two empirical equation, and we found is very useful, and therefore we include in our school building handbook. And through the research, so we can establish our shear predicting model. So as shown in here, we have short column, intermediate span to depth range column, typical column, shear wall with opening. So for this kind of test, the vertical axis indicate the test result divided by the calculated result. And the strength ratio equal to 1, it means accurate. The strength ratio, what we have, is around 1.2 to 1.15. So it seems good enough. And the coefficient of variation is around 10% to 20%. So after we establish our member behavior, then we shift, we try to find out the backbone curve for these shear critical members, such as short column, shear wall, typical column, wall with opening. So once we have this lateral load diffraction curve, then we can perform our pushover analysis. And then we shift, to in-situ school test. So every year in Taiwan, we have some school building is going to be demolished. And then we can perform the test. How to do it? The school building is in rectangular shape. So let's cut it in half. And then we use the brace to retrofit, the other part as a reaction frame. And then we put the jack in between and jack it, and then the weak part become the specimen, and we can measure, the lateral behavior. Let me show you one example for the pushover, test. Here is the monotonical loading. We push to the very last, and we can see the totally collapse of this building. And then we can understand more about the behavior. And we also perform the pseudodynamic and the cyclic loading test because we want to modeling, more close to the earthquake motion. So for this kind of test, we need the RC reaction wall. So we have to build our own reaction wall. And we use the oil jack, actuator from MTS, and we use the post-tension rod. Therefore, we can push and pull back, and we must have a very strong measuring frame to indicate, the displacement. So here is an example. That's a pseudo-dynamic test we performed in the year 2006. So you can see that we can indeed input earthquake motion and to measure the building response. So in the year 2000 up to 2007, we have two school sites. We perform the in-situ school testing. So you can see that we have the static pushover test. So we have the major curve compared with analytical model. We also have the pseudodynamic test followed by the cyclic loading test to really understand the deformation capacity of our building specimen. As for the retrofitting, the common retrofitting technology we use is the jacketing of the column. So showing example here. And we also use the infill RC shear wall, and you can do that in this way, and with some architecture design. And we also use the wing wall. Wing wall showing in here is that the two pieces of the small wall aside to the column. But in this way, we can keep the ventilation as well as the light of the school classroom. So for all this retrofitting procedure, we use the in-situ test, to verify our retrofitting method. So RC jacketing as an example, you can see that without retrofitting is the curve in black, but we retrofit using the RC jacketing, and you can see that's a curve in purple, and the strength is greatly enhanced. So all the retrofitting method was verified in this way. But before we announce to our engineer, we also use, the database to check it. So we use the Shyh-Jiann earthquake damage database of the school building in Taiwan. So this school building, they must have the structural property and contain the plan, dimension, section detail. We also have the major seismic magnitude. So it means the site PGA was measured. But we also have the damage condition report. So we have the damage record, and we have the definition of the damage. So we have totally 35 buildings contain, this message, and we use that to check our analytical model. So we classify this 35 building into collapse, showing here, heavy damage, or medium damage, or small damage, or slight. So as you can see that as long as the collapse, heavy damage, medium damage, our model indicate unsafe. So our capacity to demand ratio less than 1. But for the small and the slight damage, our model indicates safe in every sense. So it means that our method established, indeed, they can distinguish the unsafe and the safe school building. Okay, let me introduce the school retrofitting program with you. So first, we have a strategy for the school upgrading, in Taiwan. We start with the census. That's a field investigation, as I just mentioned, and followed by evaluation. So we have preliminary evaluation, and indicate and save. Then we go through the detailed evaluation. For detailed evaluation, we have the peer review, and then and save. We can go to design and the construction. So we can have either rebuild or retrofitting. So for retrofitting design, we also have the peer review, and the retrofit construction, we have the inspection. And all the process, we collect into the database. So we collect it through the internet. So then we have all the data. So very important, to unify, the process, because in this project, school retrofitting, we have a very complex party. We have a governmental officer, we have school teacher, we have engineer, we have a constructor, we have student and the parents. So they have a diverse opinions, and that's the reason why unification is very important. And besides, we have a very tight schedule. So we have an annual budget, should be checked annually. And the construction period is very short, either in the summer vacation for 2 months or in the winter vacation for 1.5 months. And so therefore, we provide a unification document. So we have operation specification for all the process, for the detailed evaluation, preliminary evaluation, seismic retrofitting. And we also have the contract document. And most important, we provide the design manual for school building. And worthwhile mention is that for budget control, it means how to pay the service payment. So for new construction, we all understand we use the design payment equal the rate times the construction fee. And therefore, the payment is based on the quantity. But if we introduce this method for retrofitting, we can see that a lot of unnecessary retrofitting will be performed. So therefore, we change. For seismic retrofitting, our payment design as design of the payment equal the rate times the floor area. So once you know the floor area, then we'll give you the certain amount for your design fee. And therefore, this try to encourage the innovation for quality. So I think this is a very important, procedure. And also for budget control, we recommend using the economical method, because traditional retrofitting method is encouraged. It means that RC jacketing, RC wind wall, or RC shear wall. And because the school building in Taiwan, they all low-rise RC building. This traditional retrofitting method, very cheap and is very effective to increase the strength is good enough. And therefore, if you talk about seismic device with a pattern, it was prohibited. So we don't use the isolated device or the damper, for our school retrofitting project. And also for quality control, review and inspection is very important. So for the peer review design, so we have 3 reviewers for each design case, and these 3 reviewers must, one, as a school professor, at least 1 engineer. So then we have 3 reviewers in the committee. In the meantime, we also invite the school staff, because maybe the teacher or the principal, they have to show their willingness for this project, what's their expectation should be included. And then through this peer review, we can see that the budget can be saved. And also, during the construction, we must have the inspection. So usually inspection was carried out by the contractor and the engineer. But in this project, we introduced the school teacher to be included. So they have to take the photo and upload it, to the ANCRI website to see at the critical point, how is the process, going. And very important is the workshop, because engineer, school administration, and the educational officer, they must have the workshop, to indicate what's the process. Especially, for each school, the teacher, they change every year. So we have a new teacher in charge of the school retrofitting project, and therefore the workshop is the only way, we train the teacher to understand the process. So we also show that a very good, case study. So if we have a good example, and then we arrange, the workshop and invite the administrator or the engineer to take a look, and we can learn from this excellent project. And more important is we use the website and the database. So we have a database in Ankry. So in this database, we use the data collecting, and we can announce the news, and engineer can download the service, and they can exchange the information. So they provide all kinds of service. But we can also use the data, and we analyze them, and therefore we can understand the process, monitoring, and also we can provide the good information for decision making. So this retrofit indeed is quite effective. So in the year 2010, we have a Shyh-Jiann earthquake. That earthquake with a magnitude of 6.4. So we have two schools side by side away from the epicenter, about 30 kilo. So you can see that one school without retrofitting, severe damage. But another school, they complete the retrofitting, so no damage at all. So that's a good example, indicate the effectiveness of the school retrofitting. So talk about the cost. If you can control the cost, is very important, make the project can go long. And then our statistics show that our actual cost for retrofitting fee compared with the rebuild fee is only about 10%. So that's about 1,000 cases. So try to lower down your retrofitting costs. Make sure this project can go for a long time. And the current process that we have, this project started from the 2009 and will be ended in the 2022. So totally in a span of 14 years. So you can see that we have our census about 27,000 school building, and go through evaluation, and SAFE goes through the seismic design, so they can rebuild or they can retrofit. And totally we already complete about 9,000 of our school building. So up to the year 2022, all the school building in Taiwan, we can have about 37%, either using the retrofitting or using the rebuild to upgrade their seismic capacity. So let me talk about the new program that at the initial phase, that's a residential building program. So in Taiwan, we have the mixed-use urban planning. So you can see that a building maybe in the first story is for commercial use, but for the upper story is a residential purpose. So during the earthquake, we find out that the first story with the open space, so it results in a soft and a weak first story. So during the earthquake, they collapse. So that's a lot of cases. So in Taiwan, it's also an urgent need, to resolve this problem. So for this characteristic of all the damaged building we observe, so they either older RC building, it means this building was constructed before the Shyh-Jiann earthquake, and also they have a soft and a weak first story characteristic. So we want to solve this kind of problem. So how to do that? Because the volume is too large, the budget we cannot afford. So we determine a strategy is that for this building with the soft, the first story, we simply remove this seismic deficiency by retrofitting the first story, either using a brace, shear wall, or we can use the external frame, to prevent the building collapse immediately during the earthquake. So let me show you one example. That's interim retrofitting cases. We use the external frame. So showing on the left, here is a 7-story condominium, but the first story is a market. So then what we do is we introduce addition of the external frame. By introducing the external frame, we simply upgrade and remove the seismic deficiency for the soft and the weak story. So during the construction, this market still operate. So I think that's the way, to do that in a much smooth and simple manner. So let me draw my conclusion. So for the school retrofitting project in Taiwan, the major feature in this project, as I can see, is first, the compulsory. So we used a few investigation, and the older school and older building were carefully examined, so to make sure they should be included in the project or not. And for technology-wise, we use advanced evaluation method. So we use the nonlinear, static analysis, and we have a, screen, process, and we can determine the prioritization and carefully. And then for administration, so we provide the unified procedure, and for budget and the quality control were carefully designed. And for monitoring, we are using the website and the database. So for the school retrofitting project, the budget-wise was provided by the central government, but all the schools belong to the local government. So ANCRI as a platform, we try to bridge the central government and the local government to carry out this project and in a much reasonable manner. So for this project, I would like to show our gratitude for the Ministry of the Education in Taiwan, also the Ministry of the Science and Technology, and the National Applied Research Laboratory, and that's our superior institution, and all the schools involved, and all the county government involved. And also, we invite the Taiwan University to join this project. So that's all, for my presentation, and thank you for your attention. So I think that in the near future, I believe in Mexico, you will have a very successful school retrofitting project. So if it is needed, so we should still exchange our information and for future cooperation. And thank you for your attention. Thank you.
Muchas gracias, doctor Hwang, por tan interesante conferencia y, por supuesto, gracias por el ofrecimiento de poder colaborar y tomar como referencia el avance que han tenido.